Hey guys, this is Hemant and welcome to the second episode of this tutorial. I hope you have seen the first episode. It might just help you understand this one better. Just as a recap, in the previous episode, we understood what FlashPunk was, we understood what bitmap blitting was, we created a new ActionScript project in Flash Builder and linked the FlashPunk gaming library to our project. We also initialized the FlashPunk engine and created a new screen or world called Game World. We finally told the FlashPunk engine to display the game world in the game initially. In this episode, we shall create objects in our game world such as hero, bullets and balloons. We'll animate the hero according to the mouse position and make the hero shoot the bullets as you click on the screen. We'll lastly make random balloons appear on the right side of the screen and animate them upwards. So here I am in Flash Builder and this is where we left off in the last episode. Before we do anything else, we'll need to copy the graphic and sound assets folder into our project. Now I have the assets folder in my desktop. I'm going to copy that, go back to Flash Builder and paste it in the source folder of my project. Now that we have all the assets in our project, the next thing is to create a hero object and add it to the game world. To create a hero object, it is obvious that we are going to make use of the hero.png graphic asset that we just copied. So the first thing is to embed the PNG file in our ActionScript project. So we shall follow a good practice of embedding all the graphic assets in a new class called GameConstants. To do that, let me create a new ActionScript class. Call that GameConstants. I'll leave that in the defaults package and click Finish. Now I shall remove the constructor of this class as I will not need that. Let us start by embedding the hero graphic asset. I'll write the embed code and the source would be assets/hero.png. I'll store that PNG file in a public static const gfx_hero of type class. Let me save it. Now, one thing to understand is in FlashPunk, any object in a world is called entity. So to create a new hero object, I'll need to create a new ActionScript class called hero and extend it from entity. Let me go ahead and create a new ActionScript class. I'll call that hero. I'll extend that from net.flashpunk.entity. I'll put that in the entities package and click Finish. As you can see, the hero class is now created. Now every entity in FlashPunk has a graphic property we can specify. The graphic property of any entity needs to be of type image, and image class resides in the net.flashpunk.graphics package. So let me go ahead and import the class image. Import net.flashpunk.graphics.image. Now that we have the image class imported, we can add the graphic property of hero. Let me do that right after the super call. We'll say this dot graphic is equal to new image of, we'll pass the embedded graphic from the GameConstant class. GameConstants dot gfx hero. Don't worry about the clip rect, we're not going to use that. Since I also know the dimensions of the graphic asset, it is a good practice to set it in the constructor of the hero entity. Let me do that by saying this dot width is equal to 60 and this dot height is equal to 60 pixels. Let us save this. The next thing is to add the hero entity into the game world. So let me switch to the game world class and create a new private variable called hero. Private var hero of type hero. In FlashPunk, in the world class, there is a begin method that gets called as soon as the world has begun. So we need to add the hero entity on the screen as soon as the world has begun. So let us go ahead and override the begin function. Override public function begin. Right, so we shall instantiate hero. As you can see, it accepts some constructor parameters. We are going to pass a couple right now. Let us set the x value to around 30 pixels and the Y value to half the height of the stage. So before I do that, I'll need to import net.flashpunk.fp. This will give me the screen height. So let me go ahead and say fp.screen.height divided by 2. We are done with specifying the initial position of the hero entity. So let us add the hero entity into the display list. We shall use the add method in the world class to add the hero entity onto the display list. So we'll say this dot add, which accepts an entity, and we are going to pass hero. Let us save this file and run the project. As you can see, the hero resides in the center of the screen vertically and towards the left horizontally. Now I know it's not vertically exactly at the center. We don't need to bother about it because he's anyways going to move up and down based on the Y position of the mouse. Okay, it's now time to move the hero on the screen based on the Y position of the mouse. We shall do that by extending the update method of the hero entity. Now every entity has an update method that executes FPS number of times. This means since our frame rate is 60, the entity's update method is executed 60 times in a second. So it makes more sense to override the update method in the hero class instead of writing our own event listeners for enter frame or any other events. Now to get the Y mouse position, we need to use the input class of FlashPunk. Let me switch to the hero class and import the input class. Import net.flashpunk.utils.input, and we override the update method. Override public function update, and we simply assign input.mousey to the hero.y position by specifying this dot y is equal to input.mousey. Now before we compile, please don't forget to call the super.update method in the hero's update method. This is very critical. Super.update. Let me just save and run the project. Yep. Now when you move the mouse, the hero moves up and down. But there's a simple cosmetic issue that he doesn't vertically align to the center of the Y mouse position. We're just going to fix that by decrementing half of his height from the Y mouse position. So we'll close it. To do that, I'm going to decrement this dot height divided by 2. Let me save it and run. Now the hero seems vertically aligned to the Y mouse position, and if you look closely, the hero moves out of the screen when the mouse cursor moves towards the edges of the stage area. So we shall fix that with a couple of simple conditions. Let me go back, and as soon as I set the Y mouse position, let me add a couple of conditions here. If this guy goes out of the screen on the top, this dot y should be forced to be 0. And if the hero goes out of the screen in the bottom, I'll need to check this dot y is greater than, I'll need the FP class, import net.flashpunk.fp. If this dot y greater than fp.screen.height minus this dot height, we need to force him back inside the boundary. This dot y is equal to fp.screen.height minus this dot height. Let me save the project and run it. We now have the hero behaving as needed. So it's time to create the bullets and shoot them upon mouse click. Just like we did with the hero entity, we'll need to create the bullet entity. So let's start by creating a new ActionScript class. We'll call that bullet. We'll place that in the entities package, and we'll extend that from the entity class. We now have the bullet entity created. Now I've not provided any PNG asset for the bullet because I want to show you that we can create bitmap data on the fly and assign it to the graphic property of any entity. Let's just do that by setting in the constructor this.graphic is equal to new image of. The source can be a bitmap data. So I'm going to pass new bitmap data. The first parameter that the bitmap data accepts is the width. So I'll pass 2, and the height is also 2 pixels, and transparency is false, and the color is gray, 666666. Let me save the bullet entity. Now we have created the bullet entity but not yet added to the game world. We'll make the hero shoot it as the mouse is clicked or pressed on the screen. So we'll go to the hero class and add a simple if condition at the end of update method. In FlashPunk, when we access the input.mousePressed property, it returns a true or a false. So yet again, we can avoid adding the event listeners. So we'll write if input.mousePressed. If that's true, we'll create a new instance of bullet class that we just created and pass the hero's x and y coordinates as the initial position. To do this, we'll need to access the world in which hero resides. So we'll write this.world.add and create a new instance of bullet, and we'll pass hero.x and hero.y. We'll save the project and run it. So as you can see, the bullets just get created as I click on the screen but don't animate yet. So let's just do that in the update function of the bullet class. As we did with the hero, we'll override the update function of the bullet class. Override public function update. Don't forget to call the super.update. Just before that, we'll need to increment the bullet's x position based on a speed. So let's go ahead and create a constant in the GameConstants class and call it bullet_speed. Now this will be of type integer and we'll assign a value of 100. This is the number of pixels the bullet needs to move per second. Let's save this and get back to the bullet class. Now you might think, if the update function is executed 60 times in a second, it is obvious that we won't increment the bullet's x position by the bullet speed constant that we just created in the GameConstants class. FlashPunk returns a very useful property called elapsed. We'll need to import the FP class to use that. So let me import net.flashpunk.fp. The elapsed property returns the number of seconds that have passed since the last frame. So we'll multiply the bullet speed with the fp.elapsed property and add that to the current x position of the bullet entity. So we'll set in the update method this.x plus equal to fp.elapsed multiplied by GameConstants.bulletSpeed. We'll run this. Now as we click on the screen, the bullets get fired, but obviously there's a small little problem. Our hero thinks too much from his brain to shoot the bullets from his head, or doesn't think at all. So let's make him think right by aligning the bullet to the gun's barrel instead of his head. So to do that, I'll go to the hero class and change the initial position of the bullet by adding the width of the hero, this.width, and similarly half of hero's height to the y position by writing this.height by 2. We'll also add an additional 9 pixels offset to align the bullets to the gun barrel. I know this value because I have designed the graphic. Now it may vary for different graphic assets, but you get the point. Let me save it and run the project. Now as we click on the screen, the hero seems to have his brains back and shoots the bullets from his gun barrel. One small recommendation I have is to remove the bullets from the world as they go out of the stage area on the right side. This will make sure that less objects exist in our game world. Well, it's a good practice. So let's go to the bullet class and add a small condition to the end of the update method. If this.x is greater than fp.screen.width, we shall access this.world and call remove by passing this. Now that we are done with the bullets, let us create and add the balloons. It is a similar process that we went through for creating the hero and the bullet entities. The first thing we'll do is to go to the game constants and embed the balloon graphic. Embed assets/balloon green.png. We'll assign that to a public static constant gfx underscore balloon underscore green of type class. I'll save the game constants. The next thing we'll do is to create a new ActionScript class, call it balloon, put it in the entities package and extend it from the class entity. We can specify the graphic property for the balloon entity using the asset that we just embedded in the game constants class. So we'll set this dot graphic is equal to new image of game constants dot gfx balloon green. Since we don't need to pass the balloon's initial x and y position from outside this class, we can pass it to the super call right here. But before we do that, let us import the fp class net.flashpunk.fp, and for the x position, let us specify fp.screen.width by 2, which is half of the screen width, and add an additional random number fp.rand, which generates a value from 0 to fp.screen.width by 2, which is an additional half of the screen. This makes sure that the balloons appear only on the right half of the screen. We'll also decrement a value of 40 to make sure the balloons completely appear inside the stage area and don't appear half outside. The value is 40 because the width of the graphic asset for the balloon is 40 pixels. Now for the y value, we are going to pass a value which is outside the stage area below the screen, which is fp.screen.height plus 10 pixels. Just before we add the balloons to the game world, let us animate them by overriding public function update. Call super.update. And just before we animate it, let us define a constant in the game constants class. Public static const balloon speed of type integer with a value of 100. We want the balloons to move 100 pixels per second. We'll go back to the balloon class and set this.y is decremented by fp.elapsed multiplied by game constants dot balloon speed. Let me save the balloon class and go to the game world. Let us add the balloon to the game world in the update function. So let us override public function update, call super.update, and call this dot add of new instance of balloon. Let me save the file and run it. Now the balloons are getting added, but obviously there's a huge problem. We just need to randomize when the balloons get added to the world. That means just before we call the add function, we need to check for a random spawn chance value. Let me explain the idea behind how we shall do it. Now we just need to randomize when the balloons get added to the world. So at every update function call, we shall generate a random number from 0 to 1. To do that, let us call fp.random, which is going to generate a value from 0 to 1. Then we'll write a condition to check if the number generated is greater than 0.95. So we'll put an if fp.random greater than 0.95. We'll add a new instance of a balloon only if the condition is true. The chance is like 5%. The rest of the 95% would be a number less than 0.95. So randomly balloons get added to the world. Now this could still be confusing and not clearer because we don't even know roughly how many balloons would appear. So to better understand this, let me define a constant in the game constants class. Public static const balloon spawn chance. This will be of type number, and since my frames per second is 60 and I want approximately one balloon to appear per second, I'll assign a value of 1 divided by 60. But this gives me a value of 2 to 5% success rate that I want, which is a value of 0.01666. So to fit to my condition, I shall subtract this value from 1. So I'll make this 1 minus 1 by 60. Now I get an approximate value of 0.97 or 0.98. I got a similar value but with a clearer understanding and a clearer way of defining the probability. So I'll go ahead and save the game constants class, go back to the game world, change the 0.95 to game constants dot balloon spawn chance. Let me save my project and run it. Now this is starting to appear like a game to me. We have random positions defined for the balloons, and we also have random time gap for the balloons to appear. If I click on the screen and shoot the bullets do get generated and animate, but they don't collide with the balloons. We'll stop it at this in this episode. In the next episode, we'll write code to make sure the bullets collide with the balloons and pop them out. So see you guys.